Now, in quants, I won't be discussing time value of money because time value of money has such concepts which are covered in fixed income, equity, derivatives. So when we discuss all those things, that time it will get covered. Okay. But basics of time value you should know. The 5 keys that we use in calculator: N, I by Y, PV, PMT, FV. N is number of periods. Remember, it is never number of years. I by Y is interest rate per period. PV present value, PMT recurring payments, FV future value. Okay, so now if I say that I have invested somewhere for 4 years at quarterly compounding, so N will be 4 years into 4 quarters per year. 4 into 4, 16. I by Y, for example, rate of interest is 10%, so I by Y will be 10 divided by 4 because per quarter. PV, whatever amount you have invested, and if you have invested lump sum, then PMT won't be anything, because in between you won't get anything. You have lump sum made an investment, and lump sum you will get it at the end of the period. Okay, so we have done those questions, just be careful about that. Also, when they ask you to find out I by Y, this especially what I'm telling you will be helpful for fixed income. If they ask you to find out yield to maturity and it's a semi-annual bond, so you will accordingly adjust N, and N you have to adjust for semi-annual compounding. Now I by Y, whatever answer you get, that will be as per 6 months. So don't forget to multiply it by 2 to convert it back to annualized basis. So these are small things that you have to remember. Okay, fine. Then coming to uneven cash flows. Uneven cash flows, CF function, we had learned CF function, CF second C by C. So first clear memory of the CF function and then start using that. What is the significance of F function in that? F is what? Frequency. So if there is back-to-back repetition of a particular number, you can make use of the frequency function. Remember, in time value of money we had done such question that I'll be investing 10 years hence. 10 years down the line I will start my investment, but I want to find out the present value today at time 0. That was a two-step sum. But then I had taught you the Calci shortcut using uneven cash flow. So if you are going to be investing starting from 10th year, and say you invest up to 15 year, so whatever 4,000 rupees per annum you are going to invest from 10th to 15th year, you want to find out the present value as on time 0. So CF 0 will be 0, C01 will be 0 again, from 1 to what is the frequency of these zeros? 9. 1 2 3 4 5 6 7 8 9. 9 is going to be the frequency, so F01 will be 9, C02 will be 4000, and F02 will be 10, 11, 12, 13, 14, 15, 16, so 6. Okay, and then whatever is the I by Y, you input that and you calculate the NPV. Fine. Okay, so this was mostly about time value of money. Also, when you are plotting the cash flows on a timeline, they always have to be end of period cash flows. So if I want to plot beginning of year cash flow on the timeline, beginning of year 1 means as good as end of year 0. So I will plot it on 0 on timeline. Just be careful about that. Okay. Now discussing about this chapter, rates and return. So first we understood different types of means: arithmetic mean, which is simple average; geometric mean, which is CAGR, compounded annual growth rate. I had shown you 2 ways to calculate CAGR. One is the compounding that you do. Say for example you have 3 returns, 15%, 18%, 9%. So it will be 1.15 into 1.18 into 1.09, and you have to take the cube root of it because you have achieved these returns over 3 years. How to solve it on the calculator, we had discussed that. Y to the power x key, then 3, then reciprocal key, -1 into 100, all those functions you remember. Okay. Other way to calculate geometric mean would be if starting and ending value is given to you. So starting value would be in PV, ending value would be FV. Ending value, by the way, is also called as terminal value. PMT would be 0, and you would input over whatever period you achieved that return and compute I by Y. That I by Y which you get would be nothing but the geometric mean return. Okay, fine. Thereafter we had, and geometric mean is useful when there are compounding effects coming into picture. Okay, so that time you use geometric mean. Simple average would ignore the compounding effect. Also, harmonic mean is to be used when you are dealing with two variables, one out of which is constant, one is fluctuating. On the fluctuating variable you apply the harmonic average. So for example, if I have five numbers 5, 8, 13, 2, 1, and if I ask you to calculate harmonic average, so in numerator you would put 5 because you are dealing with 5 numbers, and in denominator you would take the reciprocal of each number to calculate harmonic average. Now how to solve it on the calculator? I had shown you one shortcut method to solve this on the calculator. You have to first solve for denominator and then reciprocal multiplied by the numerator. Now I'm not going into the depth of all that again, but I hope you recall that. Okay, then there was trimmed mean. After harmonic mean, there was trimmed mean. Trimmed mean is when there are outliers, and outliers are troubling you, distorting the mean value, so you trim, you literally cut, you literally ignore the outliers, and whatever remaining numbers you calculate the average of that. Now nowhere has it been written how many outliers to trim. It is up to you as an analyst, it's your choice how many outliers you want to cancel. Okay, fine. Then there was Vincerized mean. Let me discuss that further when we are discussing percentiles and all. Okay, now after this, in rates and return, we had learnt money weighted rate of return, time weighted rate of return. I am your fund manager. I am only responsible for stock selection. The amount that you invest is in your control. So you judge my performance on the basis of what? Time weighted rate of return. Time weighted rate of return is what? Simple geometric average. And money weighted rate of return, if you want to calculate, first be disciplined and make a proper timeline, which we had learned. And money weighted rate of return is nothing but the IRR. If I am responsible for stock selection and the amount invested both, then you judge my performance basis the money weighted rate of return. And in the money weighted rate of return calculation, if you remember, money weighted rate of return will be dragged down if before a period of low return you are investing a big amount. Before a period of high return, if you are investing a big amount, your money weighted rate of return would shoot up. We had taken 3 investors in class, if you remember. Okay, so again, very important, and in question be very attentive that if they tell you that dividends and all have been reinvested, then accordingly factor in that thing. Okay, if nothing is mentioned, don't do anything, but timeline is a must in money weighted rate of return calculations. Okay, fine. Thereafter, we had learned several jargons. What is leveraged return? Leveraged return, I had shown you one shortcut. Whatever the stock returns, you subtract the interest charges and everything, and admin charges, whatever you subtract, and then multiply it with the leverage ratio. Leverage ratio is what? 1 upon own money. I had specifically told you not to use that formula at all which they have given in your book. Absolutely no. Okay, follow my shortcut method to be used for that. Okay, thereafter we had learned pre-tax nominal return, which is also called gross return. Now gross return are the trading charges and commissions and all deducted? Yes, they are already deducted in gross return because they are unavoidable, trading charges and all. After gross return by the way is also called as pre-tax nominal return. You will deduct my fees, I'm your fund manager. Okay, so then you will get net return. Net return may say you will pay taxes, you will get post-tax nominal return. Now from the post-tax nominal return, some invisible monster will eat up your returns. Who's that invisible monster? Inflation will eat up your returns. So what you are left with is real returns. You remember that? Okay, so these calculations are extremely important to calculate leveraged return. Also in leveraged return, one point you have to keep in mind, I have borrowed only 20% of the money and interest is 6%. Should I subtract the entire 6%? No, I should only subtract to the extent of 20% because borrowing is only 20%, right? So that specifically you have to understand that. Don't just sit to subtract entire 6%. Also, is leverage always beneficial or it's a double-edged sword? Double-edged sword. If the stock gives good returns, your portfolio will give good returns above the stock returns due to the leverage effect. But then if the stock falls, your portfolio also would fall. So if leverage is 3 and stock returns is 20%, and assuming no interest, no commission, nothing, just for sake of simplicity, your portfolio would give returns of 60%. And if the stock goes down by 20% due to leverage of 3, your portfolio also would have losses of 60%. Now, not repeating the calculations, I hope you recall. Okay. Then there was annualized return that we had learned. Annualized return was what? 1 plus holding period return, and of course whatever you mention in the bracket, it has to be in decimals. So if holding period return is 8%, so in bracket it has to be 1 plus 0.08, and you have achieved these returns over 33 weeks, and if I ask you to calculate the annualized return, it will be what? To the power 52 by 33 annualized. Weeks ka annualized basis you have to take weeks. If I say that I have achieved these returns over 137 days, then it would be 1.08 to the power 365 divided by 137. Always first solve for this, store it, and then the bracket part, recall. You remember those functions which we had learned? Okay, fine. So this was mostly about this chapter, rates and return. Again, one very important thing in rates and return was the standard deviation calculation. Standard deviation calculation we had logically understood step by step. Okay, and it was very important to understand that step by step. Thereafter we had learned the calci shortcut of standard deviation. Okay, again very important, second 7 function if you remember. Standard deviation formula was what? X minus x bar square upon n under root, and sample standard deviation was n minus 1. Sample standard deviation on calci is denoted by Sx, normal standard deviation is denoted by sigma x. Unless otherwise mentioned, you always have to answer the question in accordance with Sx, sample standard deviation. If at all it doesn't match, then you answer as per normal standard deviation. Okay, fine. Now I take two set of numbers. Okay, do you agree with me that arithmetic mean always exceeds geometric mean, and geometric mean always exceeds harmonic mean for any set of numbers? Okay, and higher the standard deviation, more is the difference between arithmetic and geometric mean? Yes, but if standard deviation is 0, so arithmetic, geometric, harmonic mean all will be the same. Okay, testable point, MCQ could be tested on this, so just be careful about it. Okay, fine. So this was all about rates and return chapter, and then little bit of theory. Nominal rate is equal to real rate plus expected inflation, and then we had discussed that for every risk that you take on as an investor, you demand premium. So if you take credit risk, you demand a credit risk premium, also called as default risk premium. If you take on the illiquidity risk, you demand an illiquidity premium. If you take on the risk of investing for a longer time period, you demand a term premium, risk of investing for a longer time period. If you invest in a country where political conditions and all are not stable, emerging markets and all, you demand a country risk premium. Point is, you keep on demanding premiums for whatever risk that you take on. Then you have to check whether what you are demanding and what you are, is that sufficient? Okay, fine. Then inflation, expected inflation, that is factored into both government bonds and private sector bonds, both. Okay, and it could be so that your real returns could be negative because the nominal returns are not sufficient to match the inflation. So that was all about rates and return chapter. Now let us move to next chapter, statistical measures of asset returns. In statistical measures of asset returns, measures of central tendency. Which three measures of central tendency? Mean, median, mode. Mean is affected by a problem of outliers. The 5 types of mean, out of which 4 we have already discussed. The 5th one is Venser, shortly discussing. Mode is what? The highest occurring value. Now mind you, not the number which is the biggest, but that number which occurs most number of times, most frequently, that is the mode. Can a data only have one mode? The data can have 2 modes, more than 2 modes, 3 modes, more than 3 modes, possible? Yes. If a data has only one mode, it is called unimodal data. 2 modes, bimodal. 3 modes, trimodal. Many modes, more than 3, multimodal data. Okay. Median is what? Median is the middle value. So in order to find out median, one golden rule that you have to know is you have to arrange the data in ascending order. And say for example, I have 5 numbers. So the third number will be the median, middle value. But if I have 6 numbers, average of middle 2 values. Okay. For even numbers, you will have to take the average of middle 2 values. For odd numbers, whatever is the middle center value after arranging it in the ascending order will be the median. Okay, so whenever outliers trouble you, you can use the median. And in class, I had discussed when typically median is your CEO's salary comparison and all that stuff. Okay, fine. Measures of central tendency was this. Then we had understood measures of dispersion. Measures of dispersion, we had learnt range, Range is what? Highest minus lowest observation of the data. Then standard deviation, sample standard deviation, again entire procedure we had learned. Thereafter we had learned MAD, mean absolute deviation. That was the same as standard deviation. Instead of squaring we take what? Modulus values. Now let me tell you, there is no calci shortcut for MAD, you will have to do it manually. Okay, modulus values means what? Negative value also is considered as positive. After MAD we had CV, coefficient of variation. Coefficient of variation was standard deviation upon mean. Lower the better. Lower the coefficient of variation, less risky is it. I mean, for every 1 unit of return, the risk taken is less. And higher the CV, riskier it is. Okay, fine. Thereafter we had learned semi-deviation. Semi-deviation, also called as target downside deviation, only focuses on the downside volatility. Now that calculation again will have to be done manually. There is unfortunately no calci shortcut for it. In question, if they mention the target threshold return specifically, then consider that. If they don't mention the threshold return in the question, the arithmetic mean will be the threshold return. Okay. Also, one thing that you have to remember is in target downside deviation, they have done as per n minus 1. So we also do as per n minus 1 only. Be careful about that. Okay. Yes, you were asking something. I will discuss that in simulation methods. Continuous compounding that you are talking about, right? Yeah. Yeah, fine. I'll discuss that in that chapter. Okay. So this was measures of dispersion. Now we had measures of location also. Apart from this, measures of location was quartiles, quintiles, deciles, percentiles. Quartiles is divided in the data in quartiles is divided into 4 equal parts. Quintiles 5, deciles 10, percentiles 100. I had told you the egregious error that they have committed in the book. So the wrong formula is n plus 1 into x by 100. If you are at all calculating the percentiles, if you want 55th percentile, so x you have to replace it with 55, and n is number of observations. So whatever you get, say for example you get 5.5, is this your final answer? No, this is simply telling you where to locate the 55th percentile. Go to 5th observation plus 0.5 of 6th minus the 5th observation. But this is clearly wrong. I mean, what they have given in the book. But you have to follow this. Okay, the right one, you know, instead of n plus 1 it should be n only. Okay, that was just for your understanding. Anyway, let's proceed. Can I say 50th percentile is the same as second quartile? 50th percentile is what? 50 by 100. Second quartile is what? 2 by 4. So up to the second quartile 50% of data is situated. Up to 50th percentile 50% of data is situated, like that. Okay, fine. In quartiles, percentiles, deciles, whatever you are calculating, again one golden rule is that just like median, here also you have to arrange the data in ascending order. Percentile gives you what? The rankings. Just because you have got 100 percentile doesn't mean that you are having full marks in an exam. You may be having 90 on 100, but you are the topper. That's when you get 100th percentile. Okay, fine. So this was measures of location. Now discussing about Winsorized mean. In Winsorized mean, again there were outliers, so I was not ignoring those outliers like I was in trimmed mean. I was replacing those outlier values with the percentile values. Now it's your choice which percentile values you want to calculate and replace those extreme values with such percentile values. Okay, so if I have 100 observations, out of which 10 are outliers, in trimmed mean I cut those 10 observations, so I am only left with 90 observations. Whereas in case of Winsorized mean, I don't cut those 10 observations, I keep that as it is, simply I replace them with the percentile values. Okay, fine. Then there was correlation. Correlation always calculated between two variables. So correlation, for correlation there was the calci shortcut, the R function. Okay, in second 7 you input, and formula wise if you see, correlation between x and y is equal to covariance between x and y upon standard deviation of x into standard deviation of y. Which measure is bounded in nature? Correlation. It is bounded in what range? -1 to +1. Covariance is unbounded in nature, it can take on any values. So correlation being more standardized in nature is widely used. Okay, What is perfect negative correlation? -1. Perfect positive correlation? +1. If you plot perfect positive correlation on a scatter plot, will the line be upward sloping or downward sloping? Upward sloping. No, -1 I said, no, downward sloping, sorry. Perfect positive correlation +1, upward sloping on the scatter plot. Okay, correlation of 0 simply implies that there is no relation. Then we had learned spurious, bogus, fake correlation. Correlation is a mathematical number at the end of the day, so any two unrelated things also you put and calculate the correlation, you will get it. But is it really a correlation between the two? It is spurious correlation, fake correlation. Okay, fine. Then A is related to B, B is related to C, and due to which A becomes related to C also is called what? Spurious correlation. Thereafter we had learned one very important thing: correlation does not imply causation. We don't know whether A is causing changes in B, B is causing changes in A. It might so happen that both are affected due to some, both could be affected due to some third factor which we have no idea about. So correlation does not imply causation. Remember that, very important. Covariance, Calci shortcut also we had learned. Okay, storage function you will have to use, recall and all that. Okay, now in this we had learned skewness and kurtosis also. Skewness of a normally distributed data is how much? Normally distributed data has a skewness of 0. Normally distributed data has a skewness of 0. Skewness of 0 means the curve is symmetrical in nature. It is equally divided on both sides, left and right. But what about kurtosis? How much is the kurtosis of a normally distributed data? 3. Kurtosis represents what? The width of the curve. More the kurtosis, thinner the tails or fatter the tails? Fatter the tails. Lesser the kurtosis, thinner the tails. Lesser the kurtosis, less risk. So kurtosis is a great indicator of the riskiness because it tells you the dispersion in terms of standard deviation, right? Okay, fine. In your book I think it is wrongly mentioned that it is the height and all of the curve. It is not the height, it's the width of the curve. How spread out is the curve from the mean. Remember that. Okay, now you need not remember the formulas for skewness and kurtosis, please. You just need to know it conceptually. If a data has positive skewness matlab skewness exceeding 0, okay, and when skewness exceeds 0, mean is greater than median, median is greater than mode. If skewness is less than 0, mean is less than median, median is less than mode. Skewness less than 0 means it is negative skewness. It is more tilted, the curve is more tilted towards the left. Positive skewness, the curve is more tilted towards the right. But zero skewness, the curve is not tilted at all and it is symmetrical in nature. Both sides it is equally distributed. And area under the curve is how much? 100%, which is nothing but what? Probability. Okay, fine. In case of symmetrical curve, on both the sides it is 50-50%. Fine. So this was about skewness and kurtosis. When skewness is 0, mean, median, mode all are equal. Okay, fine. So this was all about statistical measures of asset returns. And in kurtosis also we had discussed this concept, excess kurtosis. Excess kurtosis is always measured in relation to 3. So excess kurtosis for a normally distributed curve will be 0. Excess kurtosis. Excess kurtosis of a normally distributed curve will be 0. Normally distributed curve is also called as mesokurtic curve. A curve which has fatter tails as compared to normal distribution, such a curve is called as leptokurtic curve, where kurtosis will be greater than 3 and excess kurtosis will be greater than 0. A curve which has thinner tails as compared to normally distributed curve will be platykurtic curve. In platykurtic curve, kurtosis will be less than 3 and excess kurtosis will be less than 0. Okay, fine. Excess kurtosis less than 0 simply means thinner tails. Excess kurtosis exceeding 0 means fatter tails, and thinner fatter tails in comparison to normal distribution I am saying. Okay, fine. Now moving on to the next chapter, probability. In probability, a few terms that you need to know: dependent events, independent events, joint probabilities. Okay, dependent events also called conditional probabilities, and independent unconditional probabilities. So if I ask you the joint probability of AB, where A is conditional upon B, so how would you represent that? Probability of A happening given B happens into independent probability of B. joint probability of AB where B is conditional upon A will be probability of B happening given A happens into unconditional probability of A. Then if I ask you what is the formula for Bayes theorem, probability of A happening given B happens, I had taught you a shortcut. First invert it, probability of B happening given A happens into probability of A, leave it alone in the numerator, probability of B, leave it alone in the denominator. I had taught you the derivation also of this formula if you remember, but for exam purposes you have to remember this shortcut. Okay, Bayes theorem I am not discussing it in depth, but just to give you a gist, Bayes theorem was when the conditionality changes, and accordingly I had given you hints also how to identify and solve Bayes theorem question if you get confused after reading the entire question. Last line you have to take the hint from last line, you remember that? Okay, yes, correct. And one more important thing, in Bayes theorem I had specifically told you that what is a compulsory, tree diagram is compulsory, you have to draw the tree diagram no matter what. Okay, now if probability of A is 40%, what is the probability of A complement? 60%. If probability of B is 50%, probability of B complement 50%. Probability always has to sum up to 100. Probability of B here is 30%, B complement 70%. So just let me present it properly. Probability of B happening given A happens. Probability of B complement happening given A happens. Probability of B happening given A complement happens. Probability of B complement happening given A complement happens. Yes. Okay. Now tell me the joint probability of A and B. AB. Joint probability of AB is how much? 40 and 50%, no? Joint probability of A, B complement. Again 40 into 50%. Joint probability of A complement B. 18%, 60 into 30%. Joint probability of A complement B complement. 42%, 60 into 70%. Now if you sum up everything, it will be what? 100%. Okay, so the right ones are joint probabilities, the middle ones are conditional probabilities, and the left ones are unconditional probabilities. You should be properly able to identify this. Okay, now if I ask you guys, what is the unconditional probability of B complement? 62, 20 and 42, 62, because B complement is in both cases. Did I specify the conditionality? I simply asked you the unconditional probability of B complement. So this 62% which you told me, you have obtained that using something called as total probability rule. Okay, fine. Similarly, unconditional probability of B is 38%, 20 and 18. Okay, fine. Then in this chapter they have taught you how to calculate standard deviation when you are dealing with probabilities. We had also learned that all factors were the same, all steps were the same. Instead of simple average, you use weighted average wherever the case may be. And I had told you one shortcut from my side also, use n as 10. Remember that? If n as 10 is not working, then you take n as 20. But if n as 20 is not working, please don't go to n as 30. Okay, stop there. Fine. Also tell me, can probability exceed 100%? No. Can it go below 0? No. There cannot be negative probability. It has to be in the range of 0 to 100. Probabilities broadly discussing are of two types: subjective, objective probability. Subjective probability, everyone may get a different answer. Objective probability, everyone will get same answer. In objective probabilities also there are two probabilities. One is priori probability, one is empirical probability. Empirical probability mein you will use mathematical tools to get the answer. If I give you the question and you use mathematical tools, all of you will get the same answer in empirical probability. And priori probability is based on pure logic. We don't use any mathematical tools as such. Pack of cards, coin toss and all that, you remember? Okay, fine. So this was all that we had learnt in probabilities. The key here was Bayes theorem. Okay, fine. Thereafter, after Bayes theorem, after probability, portfolio maths is the chapter, portfolio mathematics. In portfolio mathematics, again we had calculated covariance but using probabilities. all factors remaining the same, but where simple average was to be used, here we will be using weighted average. Okay, you can use my calci shortcut taking n as 10. If that doesn't work, you can take n as 20, but a request would be not to exceed 20. If you are not wanting to follow that shortcut, you may follow the traditional method. Okay, both will give you the same answer. Thereafter, in portfolio mathematics, we had again the portfolio mathematics may to a great extent it is repetition of portfolio risk and return part 1, portfolio standard deviation formula, then correlation covariance formula, all those things. Okay, and one combination concept also we had learned in this chapter. If there are 10 stocks, how many pairs of correlation are possible? 10C2. Now to solve it on the calculator, 10 second plus 2 is equal to, okay, combination function. Okay, thereafter we had learned Roy's safety first criteria. But before teaching you Roy's safety first criteria, I had cleared your basics about normal distribution, which is extremely important. Roy's safety first criteria measures what? The shortfall risk. Higher the better or lower the better? Lower the better. Lower the shortfall risk, more is the safety provided by that portfolio. So given a choice, will you select a portfolio with highest shortfall risk or lowest shortfall risk? Lowest shortfall risk wala portfolio you will be selecting, right? Okay. And I had actually told you in Roy's safety first criteria, unless otherwise asked, don't sit to calculate probability. I had taught you to calculate probability in class just for your better understanding of the concepts. But if you have to select a portfolio out of the 3 choices, you would select that which has the highest Z value, if you remember that. Okay. So broadly speaking, in portfolio mathematics, we had discussed all this. Now, one more concept in portfolio mathematics, when they ask you about correlation, the strength of relationship, whether it is weak or strong, it's decided by the number, absolute number. Ignore the sign. Sign is only to determine the direction. Negative sign means opposite direction. Positive sign means same direction. But if they ask you strength, then you ignore the signs and just focus on the absolute number. Lower the absolute number, weaker the strength. Higher the absolute number, stronger the strength of relationship. Extremely important. Okay, fine. Yes, anything else that you need to know in this? Okay. Now, discussing further estimation and inference. Estimation and inference sampling. There were 2 broad methods of sampling: probability sampling methods, non-probability sampling methods. When it comes to probability sampling methods, there was simple random sampling where each item of the population has an equal chance of selection. So 1 by n is the probability. So if there are 100 items in the population, 1 by 100 is 0.01% chance of being picked in the sample. Then systematic sampling. Systematic sampling means what? You arrange the population in a proper logical order and you select every nth item from the population. That nth item could be every 10th, every 11th, every 12th, whatever, your choice. Then there was stratified random sampling. Strata means what? Strata means groups. You are dividing the data into groups, strata, and then from every group you are doing simple random sampling. Do I have to select equal items from every group or proportional items? Proportional items from every group. Okay. We had taken numerical examples and discussed that. Then thereafter comes cluster sampling. In cluster sampling we had 2: 1 stage cluster sampling, 2 stage cluster. In 1 stage cluster sampling, what happens is I first divide the data into groups and I select groups at random. 1 stage cluster sampling, and in 1 stage cluster sampling, whatever groups I have selected at random, from that I will study each and every item. In 2 stage cluster sampling, what happens? I will not only select the groups at random, but then whatever randomly selected groups, from that also I will do a simple random sampling. That is 2 stage cluster. So naturally the accuracy reduces. Out of all the methods we had discussed, which method is the best of all? If you see, it is stratified random sampling, because every group may say you are selecting something. Okay, fine. Then non-probability sampling methods may we had judgmental sampling, convenience sampling. Judgmental sampling, I am an experienced this equity research analyst. You remember that example? Due to shortage of time, I am studying only the important factors about the company which I feel in my experience are very important. Judgmental. Convenience sampling means you go for ease of analysis. You study those factors which are easy to analyze, not necessarily which may be important. Okay, convenience sampling. Then going further, we had discussed central limit theorem. There were several properties in central limit theorem, but the underlying message of central limit theorem was very clear. Bigger the sample size, more is the accuracy, right? How much is considered to be a large sample size as per central limit theorem? 30, more than 30. Anything exceeding 30 is considered to be a large sample size. Now, first property of central limit theorem is that you draw from the population samples of equal sizes. And you remember we had discussed mean of every sample. You calculate मीनों का mean. Meano ka mean will be equal to the population mean, bigger the sample size. Second property was that bigger the sample size, the sample means, say I have picked up 5 samples, I will have 5 sample means. Those sample means will follow the properties of normal distribution. So those 5 numbers, mean, median, mode will be equal, skewness will be 0, kurtosis will be 3, that. And then if you want to calculate the standard error of sample mean, that formula was what? Population standard deviation divided by under root n. In case if you don't have population standard deviation, then what do? You calculate sample standard deviation divided by under root n. Also remember one thing, that even if the population is non-normally distributed, it is not following the characteristics of normal distribution, but as long as you pick up samples of large size, so those sample means will follow the properties of normal distribution as per the central limit theorem. And I repeat, large size means anything exceeding 30. Okay, fine. This was about central limit theorem. Also, this brings me to a point. We had learned the concept of confidence intervals, if you remember. Confidence interval, there will be 2 bounds, upper bound, lower bound. Lower bound will be what? Mean minus standard deviation into critical value. Upper bound, instead of minus, it will be plus. Remember that. Okay, fine. Now critical values for 90% confidence interval, how much will be the critical value? 1.65. Then for 95, 1.96. 99, 2.58. Okay, fine. Now moving on, after central limit theorem, and by the way, when you are dealing with sample and you want to draw the confidence interval, though, lower bound will be mean minus standard error of sample mean into the critical value. Okay, and mean plus standard error of sample mean into the critical value. Fine. Going further in sampling, we had discussed bootstrapping and jackknife. Those are resampling methods, out of which bootstrapping is a better one. Now, what is the difference between bootstrapping and jackknife? I have a sample of size, say 8. I can do resampling how many times in bootstrapping? As many times as I want. Is repetition allowed? Allowed. And in each resample that I choose, how many data points I have to select? 8. As much as the sample size, original sample size, data points should be that much only in every resample. Okay. You can do resampling 1000 times, 10,000 times, 5 lakh times, your choice. Okay, fine. After that we had jackknife. Jackknife mein I have in original sample 8 data points. How many times can I do resampling? Only 8 times. As many numbers in the sample, I can do resampling only that many times. Is repetition allowed? Repetition is not allowed. So every resample will produce the same result because repetition is not allowed. Okay, so naturally bootstrapping is more useful as compared to jackknife. From bootstrapping we had learned one formula to calculate standard error of sample mean, and that formula was nothing but our standard deviation formula, summation x minus x bar square upon b minus 1, and here b means what? Number of times resampling has been done. Okay, fine. Can you use this formula to calculate standard error of sample median? The answer is yes, you can use this formula to calculate standard error of sample median also. But can you use this formula to calculate standard error of sample median, population median divided by under root n? There's no such formula. You cannot use this. Can be used only to calculate standard error of sample means, population standard deviation divided by under root of n. Okay, remember that. Fine. So this was all about sampling, if you remember. Okay. Now moving on to next chapter, hypothesis testing. Hypothesis testing was a game of 4 steps. Let's recall the 4 steps. Step 1, state the null and alternative hypothesis. Both are exact opposites of each other. If null hypothesis is that mu is not equal to 6, alternative hypothesis will be mu equal to, oh wait, alternative hypothesis, if I state like this, that mu is not equal to 6, null hypothesis will be mu equal to 6. Remember one thing, that in alternative hypothesis I can never write like this, mu equal to 6. The equal to condition can never come in alternative hypothesis, because then it can neither be a one-tailed nor a two-tailed test. So that is why in alternative hypothesis it will be not equal to condition, or it can be less than greater than condition, greater than 6 or less than 6. I hope you remember that. Now how to identify whether it's a one-tailed or a two-tailed test? Not equal to condition, in always first of all go to the alternative hypothesis to check if it's a one-tailed or a two-tailed test. If not equal to condition in alternative hypothesis, it is a two-tailed test. If less than greater than condition, then it is a one-tailed. And what is the significance of this? Because two-tailed test will have two critical values, one-tailed test will only have one critical value. By the way, out of the one-tailed and two-tailed test, which reflects the beliefs of the researcher more strongly? One-tailed test, because there is only one direction that it can go, so researcher is more confident when he is using a one-tailed test. Also, out of null and alternative hypothesis, which is the condition a researcher hopes to support? Null or alternative? Alternative is the condition a researcher hopes to support. Okay, I hope you are able to recall. So step number 1 was state the null and alternative hypothesis. Step number 2 was test statistics. Step number 3, calculation of critical value. Step number 4 was the conclusion step. Tell me one thing, is your test statistic affected by critical values? No, test statistic is not affected by critical value, because nowhere in the test statistic formula do we use anything pertaining to critical values. Okay, now in step 2 and step 3, your critical values and your test statistic, you have to know which formula to use when, and when to use which table to calculate critical value. Let's quickly recall that. Now you are dealing with one variable and doing hypothesis testing of mean. What is the formula for test statistic? Sample stat minus hypothesized value upon standard error of sample mean. Okay, fine. You are dealing with one variable and you are doing hypothesis testing of variance. What is the formula for test statistic? It is n minus 1 into s square upon sigma square. You are dealing with two variables and you are doing hypothesis testing of variance. The formula for test statistic was higher standard deviation square upon lower standard deviation square. I hope you remember all this. You are dealing with two variables and doing hypothesis testing of mean. Did I ask you to remember the formula for test statistic? Please avoid, don't remember the formula. It's okay if a mark is gone, but in that process you may forget everything else. Okay, the formulas were extremely complicated, and there were two types when you are dealing with two variables and when you are doing hypothesis testing of mean. Which were the two tests? Paired comparisons test and difference in means test. In paired comparisons test, are the two variables dependent on each other or independent? I had told you one technique to remember, dependent. And difference in means test, independent. You remember divorce and all that? At that technique I had given you to remember. Okay, fine. Couple, paired, dependent. Okay, fine. Proceed. Now discussing about the critical values. If you are dealing with one variable and doing hypothesis testing of mean, how do you get the critical value? From where do you get it? Z table or T table? Okay, as the case may be, and I had specifically made you write down when to use Z, when to use T table. Chalo, let's recall that. When to use Z, when to use T table. When the sample size is sufficiently large. Sufficiently large means what? Exceeding 30. We had discussed that already. And the population is non-normally distributed. Do you care? You don't care, as long as the sample size is sufficiently large. Okay. Population variance is known. Then which test to use? Z test. Z table, so you find the critical value. If population variance is unknown, you find critical value from T table. But if sample size is small, do you care whether population is normally distributed or non-normally? Yes, you care. If the sample size is small and if population is non-normally distributed, there is no test available. to calculate the critical value. But if sample size is small, population is normally distributed, then you have to focus whether the variance of populations is known or unknown. If known, then Z table. If unknown, then T table. For sufficiently large sample sizes, we had discussed any sample size exceeding 120, the Z table and T table both give you the same critical values. We had seen it in lectures. Okay, fine. You are dealing with one variable and doing hypothesis testing of variance. How to get the critical value? From where to get it? Chi-square table. You are dealing with two variables doing hypothesis testing of variance. Where to get the critical value? From F table. Now F table also mistake we had learned. Two tail test means there have to be two critical values, but in your book they have given only F table for upper tail. That's the problem. Anyway, in exam I hope they give you both the critical values in case if they ask you such a question. Now when you are dealing with two variables and doing hypothesis testing of mean, from where to get the critical values? Either T or Z depending on the case which we discussed just. Okay, fine. Now instead of following these 4 steps, if you want to do the hypothesis testing using one step only, I had taught you that method also, comparing p value with the level of significance. If p value is less than level of significance, you reject the null. But if p value is greater than or exceeding the level of significance, you fail to reject the null. The pizza delivery boy example, if you remember. Okay, fine. Efficient delivery boy less than 30 minutes and that example. Okay, fine. Moving on, significance level was what? If 90% is confidence interval, significance level will be balance 10%. If 95% is confidence interval, significance level will be balance 5%. Okay, and so on. Now let's discuss about hypothesis testing of correlation coefficient. Again the same 4 steps. Correlation coefficient, same 4 steps. Okay. So the test statistic formula for correlation coefficient, if you remember, was this formula: r into under root n minus 2 upon 1 minus r square under root. R is the correlation coefficient, n is sample size. Yes. Okay. Now for correlation coefficient, to find out critical value, you always use a T table. Okay, I have taught you how to use the T table. Just be careful about it. Okay. Let me discuss about type 1, type 2 errors. Type 1 errors. The type 1 error is probability of rejecting true null, and type 2 error is a failure to reject false null. Okay. Type 1 error is what? Level of significance. If level of significance is 5%, probability of type 1 error also is 5%. Type 2 error and power of the test have a relation. Power of the test is 1 minus probability of committing a type 2 error. Now, are the two errors completely avoidable? No. If there is, you are going to reduce one error, the other error will increase. If you are going to reduce other error, the other error will increase. So I had told you to find out a fine balance depending on what your end goals are. Okay, fine. So this was your type 1, type 2 error. If the null is false and you reject the null, then correct decision. If null is true and you do not reject the null, correct decision. I hope you remember all this. Fine. After that, in hypothesis testing, I believe we have discussed everything pertaining to hypothesis testing. One part which is related to hypothesis testing is your parametric, non-parametric test. They have given a separate chapter for it, but let me link it with this. Parametric test is an example of parametric test is normal distribution, where the parameters have to be satisfied. In non-parametric test, there will be no such parameters. And typically, when do you use non-parametric test? Let us discuss those 4 instances. Instance number 1, when you are dealing with qualitative data. If you remember, tests of independence. Okay. Second, you are dealing with ordinal data. Ordinal data matlab the data is ranked. Third, when the data does not meet distributional assumptions. And fourth, when the data has outliers. That is when you use non-parametric test. Now, I had told you when the population is non-normally distributed and sample size is small. So you had no test available at that time. But the fact is that you have no parametric test available, non-parametric test is available. Okay, can be tested in MCQs, please be careful about it. Okay. Spearman's rank correlation coefficient is an example of non-parametric test when you are dealing with ordinal data which is ranked. Mutual fund manager rankings we had taken, correlation we had calculated. So the correlation formula was 1 minus 6 summation d square upon n into n square minus 1. Okay, fine. Proceed. Okay. Tests of independence. What is the null hypothesis? That the two qualitative variables are independent. The alternative hypothesis is that the two are dependent. Second step, test statistic. Now you will go bonkers if you go to calculate the test statistic, because it takes about 10 to 12 minutes to calculate test statistic. So do not remember that. Okay, if at all, they should, in my opinion, give it to you ready made rather than you having to calculate the test statistics. Step 3 is critical value. Now here, how do you calculate critical value? From where do you get it? From chi-square table. And here in chi-square table you have to use degrees of freedom. So in qualitative variable, qualitative data, what will be the degree of freedom? Number of row minus 1 into number of column minus 1. So if there are 4 rows and 4 columns, so degrees of freedom will be 3 into 3, 9 will be your degrees of freedom, and accordingly at the sufficient level of significance you find the intersection and find out the critical value. Okay, fine. So this was about parametric non-parametric test. Yes, okay. Now moving on to next chapter. By the way, do you have any doubts in this? So now introduction to linear regression. What is the standard format of a linear regression? Y is equal to mx plus c, y dependent variable, m slope, x independent variable, c intercept term. This is a must know if you want to do portfolio risk and return part 2. Okay. What is the interpretation of slope term? For every 1 unit change in independent variable, the dependent variable will change by the slope term. Intercept term interpretation, bare minimum value of dependent variable when independent variable takes on a value of 0. Okay, fine. Now I had taught you actually how to construct the equation using the past data and then how to use to predict it for the future. Then we had done coefficient of determination. Coefficient of determination had two formulas. One was correlation coefficient, you square it, and the second one was RSS, regression sum of squares upon TSS, total sum of squares. Both will give you the same answer. R square, can it exceed 1? No. It can max to max be 1, and minimum it can be 0. Again, it is bounded by 0 to 1. Okay, fine. Now going further, we had discussed RSS, TSS and all. Regression sum of squares. See, TSS is broken down into two parts: regression sum of squares and sum of squared errors. Now, what ideally do you want to be higher, RSS component or SSE component? RSS component. SSE, sum of squared error. Do you really want the error to be high? No. So lower the SSE, higher is the regression sum of squares. So lower the error term, higher is your RSS. So therefore higher will be the R square component, which is desirable. Okay, fine. Now I am not going into the depth of it, but if you remember, I had shown you the entire calculation on Excel in class, that how your RSS changes. If your RSS increases, the error keeps on reducing. Plot diagrammatically, graphically, we had plotted it. Okay. At R square of 1, there is 0 error. So whatever is the predicted value, the actual value is also that. And predicted value, how do you denote it? By y hat, if you remember. Okay, so what was the error term? Error term was the difference between actual y value and the predicted y value. Predicted by what? Predicted by the regression equation. More the difference, more is the error term, means your regression equation is not doing a good job of predicting the dependent variable. Okay, fine. Going further, if you are asked to find out the correlation, for example, and they have given you coefficient of determination, how will you find out the correlation? From coefficient of determination, please answer. Square root. But square root of a number is positive, negative. How to determine whether positive, negative? slope term. You see the slope term. If slope term is positive, correlation is positive. If slope term is negative, correlation is negative. Fine. Okay. Now here there was a blend in this chapter. There was a blend of linear regression plus hypothesis testing. Now if I ask you, test for me whether the slope is statistically significant, the moment I say this, what should your null and alternative hypothesis be? Alternative is slope not equal to 0, because naturally in alternative you can not have equal to condition, and in null the slope equals to 0. Okay. Now also one more thing that I remember in hypothesis testing, never use the words accept the null. Always say fail to reject the null. Now there's a reasoning behind that, don't want to go into that much depth, but always use the words do not reject the null. Okay, fine. Because null is not something that you would want to accept willingly. It's just that you fail to reject it. Okay. So this you understood, and then second, third and fourth step is the same as we used to do in hypothesis testing, and many a times you would be lucky enough, we had seen the questions that test statistic critical value could be given to you ready made. All you have to do is properly be able to conclude. Even if they don't give it, fine, you should know how to calculate it. Okay, I have taught you all the Z table, T table, so in case if during adverse situation also you should be in a position to get the answer. Fine. Okay. Test for me whether the intercept is statistically significant. So then how do you formulate? Alternative hypothesis will be intercept not equal to 0, null hypothesis will be intercept equal to 0, right? Okay. Now if I tell you find the relation between dependent and independent variable, then you actually do a hypothesis testing of what? The slope term. You just find out whether the slope is statistically significant or not. We had done multiple such questions in class. Okay, there was one more way of conducting hypothesis testing of the slope, the F table way. If you remember, MSR upon MSE was the test statistic formula. MSR upon MSE. Now ANOVA table, analysis of variance, the error term which is unexplained, and the regression term which is the explained term. Degrees of freedom. How much degrees of freedom for the error term? Can you tell me? Regression degrees of freedom will be K. K means what? Number of independent variables. Naturally at level 1 you are dealing with only one independent variable, so for all practical purposes your degrees of freedom would be 1. For error your degrees of freedom would be n minus k minus 1. K is what at level 1 for all practical purposes? 1. So n minus 1 gives you n minus 2 is your degrees of freedom. Now we had discussed the logic of n minus 2 also. I had shown you on the graph Excel y n minus 2. Okay, if you remember that. Thereafter mean. So mean squared error MSE will be what? By the way, just the error corresponds to SSE, sum of squared errors, and regression corresponds to RSS, regression sum of squares, and total will be total sum of squares. Okay. Now if you want to calculate the mean squared error MSE will be SSE upon n minus 2, and MSR mean squared regression will be RSS upon 1. You remember that? Okay. Now if I ask you to calculate SEE, standard error of the estimate, is what? SEE is simply MSE, this one, and under root of that. Okay, standard error of estimate by the way was what? It was standard error means what? Standard deviation. It was standard deviation of the residual terms. Residual terms means what? The error terms. Okay, fine. It was the standard error of the error terms, standard deviation of the error terms. SEE, standard error of estimate. Fine. Okay. If there are any missing values, can you find out the other values? You can. We had solved such instances also in class. Okay, fine. Now here also if you are asked to find out the confidence interval, the lower bound will be mean minus standard error of forecast into critical value. Now standard error of forecast formula was dangerous, absolutely. I had told you specifically not to remember that. Okay, standard error of forecast formula not to be remembered. Critical value, definitely you know how to find out critical value anyway, you don't have to remember. Just 3 critical values you have to remember for 90, 95 and 99. Okay, fine. The critical values which we had discussed 1.65, 1.96, 2.58 were for 90, 95, 99% confidence interval respectively. But this was for two-tail test. When it comes to one-tail test for 90, 95 and 99, the critical values are 1.28, 1.65, 2.33. You have to remember both for one-tailed and two-tailed test. Okay, fine. Now, where will the critical value for a one-tailed test lie? Towards the right or towards the left? How to determine that? You see the alternative hypothesis. In alternative hypothesis, if the condition is like this, greater than, so that one critical value will lie on the right. If the condition is mu less than 6, that one critical value will lie on the left. Okay, fine. Okay. Thereafter, we had learnt 4 types of models in linear regression: log-log, lin-lin, lin-log, log-lin. Now, the first term always stands for dependent variable. Second term always stands for independent. So, if both dependent and independent variable have relative change, relative and absolute, remember, relative change you have to use log. For absolute change you have to use linear. Okay, fine. We had discussed the reason also, if you remember, AP, GP concept. How by taking the log you are able to smooth out the effects of exponential terms, all that stuff. Proceed. Now say for example in the question they are asking you to find out the confidence interval for the slope, and they give you the forecast, standard error of forecast of slope, and they give you one more standard error of forecast. What will you consider? Standard error of forecast of the slope term, because that's what you are finding out, no? The two values, upper bound and lower bound. Okay, fine. Anything else that you need to know from this chapter? I think I have discussed everything. Yeah, one more thing. Indicator variable. Indicator variable can take on only 2 values. Binary variable, which we call it. Binary variable. We had done a question, 0 or 1. 0 indicates something, 1 indicates other thing. It cannot take on any value other than these 2 values. Okay, fine. One more thing in this, a little bit of theory. The assumptions underlying a normal or linear regression. Do you want the error terms to be constant across observations, or do you want them to be increasing as you increase the independent variable? Constant. So that constant assumption of error terms across observations is called as homoscedasticity. But if you increase the size of your independent variable, due to which your error term also is increasing, that problem is called as heteroscedasticity. If you increase the size of your independent variable and if error term is reducing, that problem also is called as heteroscedasticity. Point is, the error term should be constant across observation. That is one assumption, homoscedasticity. Then serial autocorrelation we had run, that error terms are too predictable. If there's positive error term in one period, the next period it would be negative, then again positive, negative, positive, negative. This was a problem of serial correlation. One more assumption was that the residuals, the error term, should follow normal distribution. Okay, and one more assumption was that error term and independent variable should not be correlated with each other. If they are correlated, then what problem will happen? If I increase the independent variable, the error term also will increase. So I will always fear to use a bigger independent variable value. Fine. This theory could also be testable. Just be careful about this. Okay, fine. I think I have covered everything in linear regression. There's nothing that I'm missing out on. Okay, fine. Now let's discuss simulation methods. Simulation methods, broadly they were discussing Monte Carlo simulation. Now for Monte Carlo simulation, what I will do is I have made a proper Excel working for Monte Carlo simulation, and you will understand the entire Monte Carlo simulation just by watching that Excel working. So I will upload it on your dashboard. Watch that. So not discussing Monte Carlo simulation right now. Okay, and in that video I have discussed all the Monte Carlo simulation characteristics. Okay, fine. Thereafter, continuous compounding, continuous compounding. There are two types of compounding: discrete, continuous. Discrete is countable in nature: annual, semi-annual, quarterly, monthly, weekly, daily. Continuous compound is uncountable in nature. So in continuous compounding, for example, if you are asked to find out the ending value, it is nothing but beginning value into exponential to the power RT. Just ensure that rate of return you mention it in decimal terms. So first solve for this, second ln, so you will get this value into beginning value, you will get the ending value. Now in case if they are asking you to find out the rate of return, and in continuous compounding, how will you find out? It will be log of ending value upon beginning value, if you remember. And if this return has been achieved over 2 years, then whatever you get by doing this, first solve for the bracket part, EV upon BV, then press the ln key, and then don't forget to divide it by 2, because we want to find out the annual return. Okay, fine. Also there was one more formula, or you can mention it like this: R, if you want to find out log of 1 plus holding period return. Holding period return, please anything in brackets mention it in decimal terms, right? Okay, fine. This is what you were talking about, so I hope you recall this. Okay, now difference between normal distribution and log normal distribution. In normal distribution, the curve extends to positive infinity on the right and it extends to negative infinity on the left. But in case of a log normal distribution, the curve is bounded by 0 on the left and it extends to positive infinity on the right. Why, can anyone tell me? Because log of a negative number is not defined. And when do you use a log normal distribution? For such things which cannot take on negative values, for example stock price. But stock returns can be negative, so for that you can use the normal distribution. Okay, fine. As you increase the degrees of freedom increasing is what? Basically degrees of freedom is n minus 1. So you are basically increasing your sample size. As you increase the sample size, what about the kurtosis? Does it become less or does it increase? The kurtosis becomes less, the tails become thinner, indicating lesser riskiness. Okay, fine. So this was all about simulation methods. Okay, just do watch the Monte Carlo simulation also. You will understand it perfectly watching that. Theoretically cannot explain much on that. Practically when I show it on Excel, it's better understood that time. Okay, fine. What remains now? Big data. Okay, in big data, 3 V's: volume, velocity, variety. 4 V's, and the fourth V was veracity, truthfulness of the data. Here you see a lot of characteristics we are discussing about tech and the increasing data that is getting generated today. Okay, then we had learned machine learning. You are training the machine. Two forms of training the machine: supervised, unsupervised learning. Where is your intervention involved? Supervised learning. Unsupervised learning, the machine learns on its own, but your watch is there definitely. Where would you think the machine learns better? Unsupervised learning, because you are leaving it on the machine to see how it is learning on its own. Then we had learned the problem of overfitting, underfitting. I had given you the example of a ball and an orange, if you remember. Underfitting is giving too few criterias so that it may make errors. Overfitting is making it so rigid that it rigidly follows those criteria and ends up making an error. It doesn't use its own brain. That was the problem of overfitting, underfitting. So if I have to state it in sophisticated language, overfitting is when true parameters are treated as noise, right? And underfitting is when noise is treated as true parameter. Black box approach is what? When you absolutely get no logic between the inputs and the outputs, that is called black box approach. Thereafter we had discussed a little bit about neural networks, deep learning and all that, mostly used in hospitals and stuff, artificial intelligence, Internet of Things, that sensors and all. I had given you an example, if you remember in class. China has manufactured such a car that if you are 15 minutes away from your destination, the sensor will know and the AC and all will be switched on. That is what basically IoT, Internet of Things and stuff. These are too technical basically this chapter. Latency is what? The delay. You want high latency or low latency? Low latency, because we all have become very impatient now. So even if it is buffering, we don't have that much patience. So that is high latency if it buffers too much. Now with the advent of 5G and all, the latency will reduce, and that is what is desirable. Okay, now you also have to remember the traditional data sources and alternative data sources. Traditional data sources may business processes and all that we had learned, so just be careful about that. Text, images, social media networks and all that classification you remember. Okay, fine. So this was broadly about your big data chapter. Okay, in supervised unsupervised learning, where is the data, input data, labeled? Supervised learning. In unsupervised learning, the input data is not labeled. We had taken that example of cartoon, if you remember, ducks and all. So that was a good example to remember. Okay, fine. So anything else in quants? I hope this was helpful. Okay.